Hi everyone. In this video, I wanted to talk about the fundamentals of SIP registration. Now, any tutorial or any subject on SIP has to begin with someone understanding how the SIP registration process works. It's one of the most critical process in VoIP deployments. So it's very important that you understand that this concept very clearly. Initially, when SIP came out, the whole idea of SIP as an application layer protocol was to for for you to locate end devices, and then for devices to basically talk to each other, and when they want to talk to each other, they should be able to negotiate what parameters they want to use in that session. And SIP allows for that. And that's the whole idea of SIP. End devices, I should be able to discover and locate end devices, and I should know your exact location. So you could be anywhere in the world, and if a call comes in for your phone number or your extension, I should be able to forward that call out to you wherever you are. And for that to happen, I need to know your location, and registration is the process by which we determine that location. So here's a quick diagram, a very like a bird's eye view of how the registration process works. I have a user whose phone number is 214-555-5555, and the user is located at 66.10.10.1. And then I have another user which is at 214-666-6666. That user is at 65.10.10.1. Both these endpoints send a registration request to what is called as a SIP registrar or a SIP server. Now, SIP registrar is essentially an entity or a logical device or entity which is which can or cannot be a part of the same SIP server. So it has a database where it maintains all the SIP endpoints, and it maintains what is called as a binding table. So what is the binding table? So let's look at this diagram and go through this call flow to understand what the binding table does. So the first step is the device comes up, and it's pre-configured in this case with the registrar's domain name. So it does a DNS lookup, finds out what the IP address is of the registrar, sends the register message to the registrar, and says, hey, you know what, I'm at 214-555-5555, and I can be reached at 66.10.10.1, and I would like to keep this registration active for an hour. The registrar looks at the register message. There's, in this case, we are keeping it simple. There's no authentication being done here. Very plain and simple. Turns around, sends a 200 OK, and says, I know that now you are at 66.10.10.1, and I want you to come back in 1800 seconds and refresh this binding. Once this happens, a binding table is created in the registrar, and this is the key. The binding table has information like phone number, what public IP address it has, what port number came in, and it also has a private IP information in case of firewall. But in our case, we're keeping it very simple. Everything is on the internet, everything is open. The same thing happens with the user ID 214-666-6666, where it comes in with a register message, says I'm available at 65.10.10.1, and I would like you to keep my binding for about 3600 seconds for an hour. SIP server comes back and says, okay, I have updated my binding table, and you are good to go, but come back in 1800 seconds. Now, what does the binding table do? So the key is, so when a call comes in for any of these devices or any of these endpoints, a call comes into the SIP server, and it says 214-555-5555. The SIP server looks at the binding table in the registrar, and says, the last I checked, this one was 66.10.10.1 at port 5060. So the invite comes in, I turn around and send the invite to to 66.10.10.1, that IP address, and if he's still available, he'll turn around, respond with a 180 ringing, and the call will be completed. So that is at very high level how the registration process. So here's a look at how the registration would look if we are using any sort of authentication. So here there is a four-way handshake. There is a register message coming in from the user agent. The registrar now turns around and sends a 401 asking for, it's basically sending it some parameters and checking whether he is who he says he is, and the registration comes back with an authorization header, and the 200 OK goes back. And I want to go through the details of what these www authenticate and authorization header have in it. But what at a high level what they have is authenticate, the header has some sort of a one-time password which is called as nonce, and the user agent takes that nonce. He has a username and a password associated with his account, uses that nonce, creates some sort of a hash, and sends that hash back in the authorization header back to the registrar, and it also sends what kind of realm that it used to create that hash. The registrar takes that, generates its own hash, and verifies this information. And once it verifies that this is the SIP UA, has the right user information and password, turns around and then sends a 200 OK. So it's it's still not as secure as you would expect it to be, but there is some level of security. Now, if this was to be completely secure, you would do some sort of an IPsec or TLS before this, and write a SIP over it, and that way the whole session is encrypted, and you don't have to worry about security. So this is still was done to add on some level of security, if not any. So now that we've looked at this, I want to go through a Wireshark trace of the register method, and then I'll go through each and every header and explain to you what could go wrong if those headers are not correctly configured. So let's look at that. Okay, so let's look at a packet capture of a registration call flow. So you have a register message going in here from this source address to this destination. You can see here the first line, which is the request URI, has register SIP and the name or the domain name of the registrar / proxy server or the server. Now, in most cases, when you're troubleshooting why a SIP registration is not successful, you have to start from here. Some proxy servers or some servers out there, or SIP servers out there, are very particular about this domain name. If it does not match exactly how it's configured on the server, the registration is going to fail. Now, at times, this information, the request URI, can be a domain name or could be an IP address. So if you have a small gateway in your like a small AdTran or Edgewater or something in your in the customer's premise, those guys might not have a domain name. They might have like an IP address. So if that information does not match the request URI, you might end up seeing a 403 coming in saying we don't, it's forbidden. So keep an eye for that. Now, from header and to header, typically in case of a register message, is always the same. So you would see in the from header typically a phone number, again a fully qualified domain name, or an IP address. Again, the to header would typically be the same also. Now, in there's a from and to. So the only where I have seen the from and to being different is when there is something called as a third party registration. So you have a third party proxy which is basically doing registration on your behalf, and there are applications which use that. So it's not necessary that the from and to header will always be the same. There are cases where they may be different, but very rarely would you see that. So again, if your from header has the phone number, and again if it does not match, what I have seen in my experiences, the from and to header, if the domain name again is incorrectly configured, or you have if the server uses an IP address, then the registration might fail. So you have to be very cautious of when you're troubleshooting why registration has failed. Come and look at the from and to header and verify that that information matches that in the SIP server. Call ID, again a unique identifier for the complete registration state. So as you can see here, I have actually filtered this whole flow using the call ID. So you can, if you're not familiar with Wireshark, you can apply this as a filter right here, and you can see that the whole register 401, register 200, the entire call flow has the same call ID because it maintains the same session state at the end of the day. The CSEC is 1. This is the sequence number, which is used like SIP rides over UDP for the most part. If this was TCP, it uses its own sequence number, but application layer protocol has the way it's designed, it uses a sequence number. So you would see a sequence number 1 for the invite. For all the major headers, you would see a sequence number associated with it. So if once the registration, once the 401 is completed, you would see the registration with the increased sequence number. So you'll see the CSEC increase here to 2. Once the registration is complete, you have a 401. Once the registration is received by the SIP server, the 401 message comes in, and this is where it's asking for credentials. So as I mentioned in my previous slide, you would see www authenticate header. So it says that it uses MD5, so it wants the end device to use this realm and this nonce, which is a one-time password only. After this session is concluded, that nonce goes away. Use that information and generate a hash using the username, password, realm, and nonce, and send that response back to me, and I'll verify whether you are a legitimate user. So now once the 401 is received, you can look at the response coming back from the user agent, and again everything is the same. The call ID remains the same, and you can see the authorization header. This is what you have to look for in case of the registration that comes back after the 401. So the initial registration does not have the authorization header. The registration that comes back after the 401 will have the authorization header. So one of the other things when you're troubleshooting is you would see this call flow where a device just is not configured with the right username password, or it does not have a username password configured. It's not configured for authentication. It would send a register message, and then it would get a 401. Then it would turn around, send a registration message again, and there would be no authorization header in it, and again it would get another 401. So you would see this register 401 message exchange continuously, and then eventually the whole process would fail. So that's something which is a signature that that the particular device has not been configured correctly for authentication. So just keep that in mind. Again, so authorization header comes in. It says this is my username. This was the realm I used. Then I use this nonce. Obviously, it's not going to send the password in clear here because everything is in clear. So it sends the URI, and this is my response. So, and I used MD5 hash to generate this response. Once the registrar receives this, it generates its own hash using the same values, and if everything is correct, if nothing has been modified, it would come up with the same hash result. If they match, it turns around, sends a 200 OK here, and it says, you know what, this is successful, the registration is successful, and I have created a binding now where I will associate your contact URI as SIP 504 or whatever, in this case whatever it is, at this IP address. The key is that it knows which IP address this device belongs to, and that's how the registration process works. I hope this was helpful. If you have any questions, leave the comments and I would try and answer those as quickly as possible. And I wish to continue to do this with basic SIP chapters. So the next session would be on troubleshooting SIP related call flows. So thanks for watching.